The first method that I want to talk about when talking about searching in arrays is the array.indexOf method. IndexOf performs a linear search through a one-dimensional array and returns the index of the first match that it finds. If it doesn't find a match, the method returns -1. You can use the array.lastIndexOf method to perform a search starting at the end of the array, searching linearly forwards. Okay, so I have a testIndexOf method that shows how to handle success and failure when searching. So the method starts out by creating this string array of states within the United States. And it actually has Washington, D.C. and some of the territories as well. So it's a little bit bigger than just the 50 states. Okay, so I create that array. And now I want to find a state within that array. So I save that in a variable called state_to_find. And I use the static method of the array object, pass in the array that I want to search, and then the value that I want to search for. And this can be a literal string as well. So that returns an index. Remember that arrays are zero-based, so the first state, which should be Alabama, it's actually in Alaska, so they're not in alphabetical order. So the first one is going to be Alaska. So that's going to be zero-based if I was searching for Alaska. And then I can check to see if index is equal to -1. If it is, then that state wasn't found. Otherwise, I'm going to write out the state that I was looking for, and it was found at whatever position. And then I write a blank line, write a prompt, and then I allow the user to repeatedly enter multiple states. And so I read a line from the console window, and then I continue executing this do-while loop as long as the user enters a state. All right, and that's the end of the method. Okay, so let's see how this works. So the first time through, it's going to look for Texas. So I'm going to hit M, and Texas was found at position 45. Okay, this time I'll search for Alaska. Near and dear to me, was found at position 0. And let's do Vermont. And it's found at position 49. Keep in mind, this is the position in the array. I haven't sorted the array, I haven't done anything like that, so it's just the whatever position within the array itself. And then when I'm done, I just hit enter. That leaves state_to_find null or empty, and that breaks out of the loop, and then I can hit any key and end execution. Okay, so that's one way to search. There's another method called array.binary search. This searches a one-dimensional array for a specific value using a binary search algorithm. The binary search method can only work if you sort the array to be searched before calling the method. So this kind of search is going to be significantly more efficient than using the linear search algorithm that's employed by the IndexOf and lastIndexOf methods. If the search succeeds, binary search returns the index of the matching item, just like IndexOf. If the search fails, the method returns a negative value indicating where in the array the value would appear if it were in the array. Because they're sorted, so it can tell you where it would fit into this array. All right, so I have the same array of string state names. Keep in mind that's not in alphabetical order, so Alaska is before Alabama, Washington, D.C. is right there. I think there's probably a few other ways that it's out of order. All right, then the code here is similar to the previous example. So I'm going to first search on Texas. But now, because binary search has to use a sorted array, I'm going to sort the array. Now this is just strings, and strings support the iComparable interface, and so I can do this on those string values. All right, I have a do-while loop again, and there's the binary search. Once again, pass in the array and the value that I want to find. Okay, so if the index is less than 0, state wasn't found, but it would have appeared before item that. I'll talk about that in just a second. Otherwise, if it's 0 or greater, then it's the same information as before, the previous example. State to find was found at position whatever. Okay, and then the rest of the method is the same. It's going to continue looping as long as the user enters a string to search on. Okay, so what's this all about there? Well, if the search succeeds, the method returns the index of the first array item containing the value that I'm seeking. If the search fails, the method returns a negative number, which is the bitwise complement of the index holding the first value larger than the value you were seeking. And I don't make this stuff up. So this is the way it works. Bottom line is that you can calculate the correct next larger value by taking the negative of the result and subtracting 1. And so that's what that code does right there. So what this is going to do is it's going to return the bitwise complement of the search result value. Okay, you can also do this with the bitwise complement operator, which looks like a little tilde, in order to calculate the value as well. All right, go ahead and run this code. Press F5. Binary search is N. Okay, Texas was found at position 44. I'll search for Alaska again. And now it's found at position 1 because the array is sorted. I'll search for Vermont again. Okay, that's at position 46. I'll search for France, not the state in the United States. So France wasn't found, but it would have appeared before item 9. Okay, so a different way of searching an array. And it turns out that this is much faster than index of. If you have a huge array or a lot of complex values that you're comparing, then this tends to be much more efficient. Okay, the methods for searching arrays that I've shown you so far work fine, but they only work on single-dimensioned arrays of simple values. What if you have an array containing file info objects, and you want to find the size of a file with a particular name? What if you have an array of objects, and you want to retrieve an array that contains all the elements that match a particular criteria? The .NET Framework provides support for many advanced searching techniques, all involving techniques that are all slightly beyond the scope of what I'm discussing now at this point in learning C#. But on the other hand, none of these techniques are terribly difficult or complicated, so it's worth taking a little time to investigate how you can get started using these more advanced techniques. And once again, these techniques that I'm going to be talking about now rely on generics and delegates. So we'll get to those in this series of C# courses, but we just haven't covered them yet. But again, the good news is that you don't need to have a deep understanding of those topics in order to use these techniques efficiently. So, the array class provides a set of methods that allow you to specify a procedure that it'll call, in turn, for each element of the array. The procedure takes a different action depending on the particular method that you call. The class provides too many of these types of methods to cover all of them here, but you can get the idea of how these methods work with a single example. Imagine that you have an array consisting of file info objects, and you want to retrieve a second array containing all the file info objects corresponding to files that are smaller than a given size. You could, of course, walk through the array yourself, checking the size of each element, and for files that are below the size threshold, copy the file info object into a new array. This means that you have to manage the loop that iterates through the original array, and you have to manage the size of the output array as well. Keep in mind that arrays can't resize themselves. You have to write code to resize the array as necessary. One of the methods of the array object that you can use to do a search like that is array.findAll. So this lets you specify a procedure to indicate what you want the array to do with each element. In this case, you have to provide a method that returns a Boolean value for each element, indicating whether you want the item in the output array. So the sample code here contains this check for small files. Check for small file is the name of the method. Returns a Boolean that indicates whether or not this meets the criteria so that we can include it in the array of found elements. So again, this is going to be called for each element of the array. And if the method returns true for an array element, the output array contains the current element. If the method returns false for an element, then the output array doesn't contain that element. So I'm just passing in file info. I'm reading the length, which is the size of the file. And if it's less than 1,000, I'm going to return true, indicating that I want that file. If it's greater than 1,000 bytes, then it's going to return false, and that file won't be included in the results. And then here's a method that tests it. So in this case, I'm getting all of the C# files that start with the letter C. I basically needed more files from throughout the subdirectories of LearnNow for various sizes, but I didn't want too many, so I just filtered it down like that. Okay, so here's the enum that I pass in to indicate that I want to search all directories within the LearnNow folder. And then I get, as a result of that, I have an array of file info objects. Just like previous example, it just happens to be a different set of files. And then I'm going to display the file info, so that's going to display all of the files that it found. And then I'm going to use the findAll method right there, pass in the array that I want, and pass in that method. Actually, it's the address of that method, because this code, this findAll method, is going to call that method, this one right here, on each element to determine whether it's going to be included in the output array. Okay, and so the result is that I get another array of file info objects, but it's the output files, and it's the ones that have a size less than 1,000 bytes. I'll start up that. And hit O for test findAll. And there you can see all of the files that start with C and that are in that LearnNow folder. And then, as it turns out, there are 3 that are less than 1,000 bytes. And again, this is a second array that was generated using the findAll method. Okay, so that's just one of the methods that you can do this sort of thing. But there's other methods that work like findAll, including things like true for all, exists, find last, remove all, find index, find last index, and so forth. So a lot of different ways of performing this kind of a search on an array.